Astronomers have presented information that indicates that the black hole at the center of our Milky Way has a mass of 4.6 million suns. Information presented ranges from those on black holes to those on gravitational waves. A supermassive black hole, which is at the center of our Milky Way, is quite interesting. Approximately 2 decades ago, there was limited evidence that such an object existed in our galaxy. With the advances and new development in technology, the evidence of the existence of a supermassive black hole at the center of our Milky Way galaxy is currently overwhelming. The black hole has a mass of 4.6 billion suns. If you were to take into consideration that the sun is about 500,000 times the mass of the entire Earth, then this black hole is more than 1 trillion times more massive than our Earth. As it stands, you can calculate the mass of any stellar object just by measuring the orbit of another body going around it. If you were to measure the mass of the sun, you can do so by understanding the Earth's orbit. If you wanted to find the mass of Jupiter, then you can measure the orbit of one of Jupiter's moons. To astronomers and researchers who are skilled in this area, it is quite simple. Advances and development in technology have made it possible to get the mass of our galaxy's black hole. They utilized 2 primary factors to contribute to same. One is from building large telescopes that are designed to look at infrared light in the night sky. It should be noted, however, that infrared light is invisible to our eyes. Electronic sensors like those in our phone's camera can be built to detect infrared light. It turns out that our Milky Way has a lot of gas and dust between Earth and the center of the galaxy. Distance between the Earth and the center of our galaxy is approximately 25,800 light years away. Infrared light can penetrate the dust, giving a clear view of stars that orbit the black hole. The next factor that contributed to this is a technique called adaptive optics. This is where the telescope can make near instantaneous adjustments to the shape of the telescope's reflecting mirror to compensate for distortions of light passing through the atmosphere. If you were to consider looking past the top of a hot barbecue, you can see a wavy distortion due to the swirling hot air above. In a similar way, the air above a telescope is constantly moving and causing distortions in the stars that it is viewing. With the new technology, astronomers can clearly observe stars that orbit the black hole at the center of our Milky Way galaxy. So they know that it exists. However, what remains a mystery is whether or not they can solve the idea and the theory about how it got so massive. It may take the next generation of astronomers to find the answer to the question about how this black hole at the center of our Milky Way galaxy grew to such a massive size. The center of our Milky Way is a black hole known as Sagittarius A. It is 4.6 million times more massive than our Sun. The supermassive black hole and its enormous gravitational field governs the orbits of stars at the center of our Milky Way. There are several types of black holes, and scientists believe that the supermassive black holes may be connected to the formation of galaxies, as they often exist at the center of the massive star systems. However, they are not clear about which was formed first. A black hole is a place in space where gravity is so strong that neither particles nor light can escape from it. Close to Sagittarius A is a dense cluster of stars. Precise measurements of the orbits of these stars allowed astronomers to confirm the existence of this supermassive black hole and to measure its mass. For more than 2 decades, scientists have been monitoring the orbits of these stars around the supermassive black hole. Based on what they have observed, they are able to say that this supermassive black hole may have a neighbor. So there might be a second black hole close by to Sagittarius A. They estimate that it is at least 100,000 times the mass of our Sun. It should be noted that almost every galaxy, including our Milky Way galaxy, has a supermassive black hole at its heart, with masses of millions to billions of times the mass of our Sun. Astronomers are still doing research to discover the reasons why supermassive black holes exist at the heart of galaxies. One idea is that the possibility that supermassive black holes also have neighbors that are similar to them. To understand this theory, however, they need to look at the universe when it was just 100 million years old. They were much smaller than today's galaxy, about 10,000 or more times less massive than the Milky Way. Within these early galaxies, the very first stars that passed away created black holes of about tens to thousands the mass of the Sun. These black holes sank to the center of the galaxies. They became the heart of their host galaxy. Since galaxies evolve by merging and colliding with one another, collisions between galaxies will result in supermassive black hole pairs. And this is a critical part of the theory. The black holes then collide and grow in size as well. A black hole that is more than 1 million times the mass of our Sun is considered to be a supermassive black hole. Like, comment, share, and subscribe. Let me know what you think about this supermassive black hole, which is approximately 4.6 million times that of our Sun. Thanks for watching and goodbye.